Facilitator today is Mr. Mark Borchers. Mark is a founder of the company Sustainable Energy Africa, which is a not-for-profit organization established in 1992. And he has a long history. He's been a director for 26 years. He's now a technical specialist within the organization. If you look at the pedigree of the work that Mark has facilitated and organized through SAIEE, it is really amazing and substantial. I looked through the documents that they've tabled, and they're all building blocks for embedded generation in South Africa. They're looking at things like the distributor's guide, metering guides, information on setting up tariffs, and sizing of equipment in networks, and so on and so on. So we have a substantial power here facilitating our session today. And without further ado, I hand over to Mr. Mark Borchers. Thank you, Mark. The floor is yours.
Thank you, Marcus. All right, so let me fire up my presentation and then we can launch the rockets. Okay, so hopefully my presentation is now visible. I'm going to assume it is. So yeah, thanks for that introduction, Marcus. So you've given us the overall context and what we're focusing on. So my job is not just the facilitation, but also to give you a bit of a background input, introducing the topic which the speakers will then do more deep dives on. So that background is mainly going to come from my experience with municipalities and embedded generation, which started about 10 years ago now that I think about it. But more specifically in the last 5 years, I've been involved with a support program for municipalities around embedded generation. And that detail, I think, is what I'm going to try and bring to you to give a bit of context for some of the deep dives which our speakers will do. So we have quite a full lineup. We've got a set of 5 great speakers, but it is quite jam-packed. So once I've given my context, we're going to go through the various speakers in order that you can see them. I'm not going to go through it. I will introduce them at the time, and then hopefully we will have a panel discussion. But let me also, if there's time, we hopefully address some questions that the participants have. So at the bottom of your screen, you should notice there's a chat as well as a Q&A. Now in the chat, you're welcome to post whatever comments that strike you, that might be useful to others. And in the Q&A, if you would like any issues addressed by the panel, then please put them in the Q&A. And Marcus will keep an eye on that and then bring them into our panel discussion at the end. We might not be able to answer all of the questions, but hopefully some of them we will be able to address. All right, so let me jump in. We have a lot to do, and hopefully we be able to stick to our time and wrap up at 1 p.m. Okay, so everybody is quite used to this diagram. We have the municipal distributor, bulk purchase, distribution to various customer groups. That's what municipalities have been for many decades. But things are changing. So the picture that I'm going to put together now is one that you have seen many times. But I'm going to bring a particular angle to it just based on where municipalities are at the moment and how they are managing various challenges which are coming into the standard operational model of municipalities. So firstly, there's the embedded generation on a smaller scale. That has been happening for quite a few years, and municipalities are in general prepared for this. There are systems in place. So I would say at the moment municipalities are managing reasonably well with this. On the larger scale, we're connecting larger generators into the network. It's newer. It really has come about, or the pressure on this has come about in the last year or so, since the Schedule 2 revision of the Electricity Regulation Act. So this is new for municipalities. I'm going to talk about some of these in more detail just now. So this pipeline is not flowing smoothly yet, whereas I would say on the small scale, it is much more of a free-flowing pipeline of generation connections. Then along comes battery storage, and then on the small scale, storage is happening already. I've spoken to a number of solar suppliers who, for smaller systems, they install with batteries. They're not able to supply inverters which are not at least storage ready. So storage is happening as we speak on the small scale, certainly. And then on the large scale, utilities are thinking about how to integrate them into the systems. And we have one of the presenters that I will introduce in due course will go into this in more detail. Municipalities are being asked to facilitate wheeling, and that comes with a set of institutional demands. While all of this is going on, energy efficiency initiatives are taking place, and users are responding, customers are responding to high prices. Demand is leveling off, as we've seen around the country. Electric vehicles are coming. It seems like it's going to be big. Quite what the implications are it's still being worked out. And on top of that, municipalities are looking to procure their own generation. So this is quite a cocktail and quite a difference from the old way of operating for a municipality. There are lots of challenges here, not just on the hardware, but on the institutions. And what I'm going to do is take a few of these and just talk in a bit more detail as to how municipalities do things at the moment, and can that take us into the future. I'm not going to go over the entire picture, but just select a few of these for a more thorough discussion based on the experience that the support program has. And then our presenters are going to do some deeper dives. As I mentioned, we have one presenter, Professor Gomes, who's going to talk about storage in more detail. Hendrik Raedeni from Ekurhuleni is going to talk about municipal procurement of larger generation. CSIR Warrick Pierce is going to talk about a more integrated look at bringing generation options into the picture. Monique Leroux from CSIR is going to talk about grid impact assessments and hosting capacity assessments and tools that CSIR has developed around that. And Mfundi Songo from Eskom is going to talk about the Eskom perspectives on such integration. Right, so let's move into generation connection. So this table comes from one of the supporting documents which the support program provides to municipalities, and it shows you for different generation sizes down here on the left, the sorts of ways that you can look at grid integration and whether they can in fact connect to the grid without adverse impacts on the network, or what you need to do to assess that. And you can see on the smaller scale here, the LV systems, they can be connected by something called, by using what is called the simplified connection criteria. I'll come to that in a minute. But all of the rest need some sort of grid impact studies or beyond. And as you get to these larger generators over here, it's not just the grid impact studies. There's grid code compliance and many other approvals and processes which kick in. I'll touch on some of these in a moment. But let's just start over here looking at the small scale side of it, because the vast majority of applications, not necessarily capacity, but applications that municipalities get are solar small scale. So let's see what's happening at the moment in that regard. So why small scale? Well, because a lot of small scale makes big scale. The last estimates I've seen, I think, are something like 1.4, 1.5 gigawatts of embedded generation on the grid nationally. So yeah, that's important for the overall picture. And then secondly, this takes a lot of municipal officials' time processing lots of small connections, particularly people wanting to connect, residential customers wanting to connect embedded generation. So in terms of municipal resources, staff capacity, it's quite demanding. So how do they do things at the moment? Well, there are two really important documents which municipalities use. One is NRS 09721. You needn't worry about the numbers, but it really is around utility interface. And effectively what this does is condense, or you can think about it as condensing the requirements for low voltage, smaller generators in the grid code into something that can be used for such connection assessments. So almost all, I think all municipalities would use this document, and in the case of solar, they would require that inverters are certified according to this utility interface document. So it makes it very simple. The utility just needs to see that that certification is there, and they will approve at least this component of the system because it covers the power quality and safety aspects. Another really important document in the municipal process is what's called the NRS 09723, but I'll just refer to it as a simplified connection criteria. So just take a step back. All generators actually need to be assessed for their impact on the network, strictly speaking. But of course, that's crazy to do for a whole lot of small applications. So what this document does, it has looked at typical network configurations and said that as long as the generators are within particular parameters, they can be approved without fear of adverse network impacts. And those parameters are to do with the local transformer sizes, generator size compared to your notified maximum demand, other generators on that part of the network, etc. So this is a really important document in streamlining things and seeing that you don't have to do detailed assessments for the smaller generators. And then, of course, if it's beyond a particular criteria within the simplified connection criteria, then you need to look at more detailed grid impact studies. And at the moment, the simplified criteria goes up to 350 kVA. But let's just look at this in a little bit more detail, since it's a really important part of streamlining this whole flow of embedded generation application processing. So the simplified connection criteria is based on typical network configurations, really. And of course, networks are not really typical. And you can see by the picture on the left, which is an assessment of the hosting capacity in a part of Cape Town, that even in a fairly small area, hosting capacity varies hugely. The dark green is high hosting capacity for embedded generation, and the red is low hosting capacity for embedded generation. So a lot of people think the simplified connection criteria, I think particularly industry or developers, consider that it's very conservative and you can connect a lot more than it indicates to the network. And I think that is often true, but sometimes it's not true. Sometimes it's actually lenient because the network characteristics vary quite significantly in different places. And then the other thing that the simplified connection criteria doesn't necessarily do too well is cater for things like, or one other thing that it doesn't do too well is cater for things like seasonal load profiles. So you can see this is a load profile from Robertson, and this blue line is what might be considered maybe a more typical load profile, which doesn't vary much more than 20% over the year. In Robertson, it varies a lot more than that. And that is largely driven by wine industry. So this would be a typical wine cellar load profile at the bottom over here, with the first part of the year, a lot of load, and then very little for the rest of the year. Now, the simplified connection criteria says if this is your notified maximum demand or your peak, you can install a generator of this size over here, which is fine for part of the year, but you can see how out of proportion it becomes for the rest of the year. And there are impacts on the system voltages, which Robertson has been concerned about because of this. So they have in fact put in place other parameters in addition to the simplified connection criteria to try and cater for this. So where are we how do we streamline things and make this pipeline of generation connections easier and quicker and faster into the future? Well, in terms of the simplified connection criteria, that document is being revised. The working group is busy looking at it and considering a revision because at the moment it's quite old. Part of that revision is they are increasing the capacity from the 350 kVA, which I mentioned earlier, up to 1 megawatt, which the experts tell me is an easy enough thing to do. So that I think is very promising. And then it could also include things like additional guidance around the seasonal load, which I just mentioned. Because municipalities tend to want to adopt the document as it is. Not many municipalities have the capacity to assess the document and see whether it is appropriate for their load profiles, etc. So the more that can be included in this document, the simplified connection criteria, the better. And then outside of the simplified connection criteria, there are a couple of initiatives to look at online applications, and the support program that I talked about earlier, as well as the City of Cape Town, are both looking at ways of streamlining applications, focusing on the smaller ones, so that the online application and potentially even approval can be entirely an online process. So that's the screen grab of what the support program's online platform might look like. It'll be accessible to all municipalities, all people wanting to install systems. You can use a GIS viewer to select your location. And importantly, for the municipality, it tells you if you have entered the data, other generators that might be in that area, because of course, networks have certain hosting capacity beyond which they can start to become out of bounds in various ways. So this hopefully will streamline that process quite a bit. And there are people such as Ishmael Jeffries within the City of Cape Town that are looking at having this entirely automated. In other words, no input from a municipal official necessary for approval to install to be given. So I think that's really promising, and I would support that move. And we are in communication around trying to achieve that. Right, so on the tariff setting revenue impact side of embedded generation, this graph over here, some of you may have seen, it is looking at a particular tariff category, residential, and connecting solar embedded generation. And this is the penetration level over here. So this over here would represent 20% penetration into that tariff category. And this over here is municipal change in revenue when a customer moves from a normal residential tariff to an embedded generation tariff. So here we have, for example, up here, this would be revenue positive for the municipality, but a poor business case for the customer. These are, by the way, actual tariffs taken from various municipalities. They're probably about a year or so old, but I think they be able to illustrate the principle adequately. So over here, revenue positive for municipality, not a good business case for the customer. Over here, revenue negative for the municipality, good business case for the customer. And what we have, of course, been encouraging municipalities to do is set tariffs such that they are reasonably revenue neutral, that they are okay for the municipality and the business case is okay for the customer. So we've been doing this for a while, and I think in general, municipalities have got this under their belt and understand how to set such tariffs. There used to be resistance, for example, to giving export credits. I think that is now a thing of the past, and most municipalities are doing that. So I would say as a country, we have this in hand. But then, of course, along comes battery storage. And we have just done some initial work to look at what the impact of battery storage is. And on the small scale systems, it seems like it adversely affects the municipal revenue picture. And that obviously makes sense because if I'm a house and I have solar panels on my roof, and I am now I'm exporting less to the municipality, I'm using that to charge my batteries. And municipality likes to get export power, or they should, because they can compensate the customer at possibly 70, 80 cents a kilowatt hour, and then they can on-sell it for 2 rand. So that's a source of revenue. They can even get a better markup than they can from the Eskom purchases. So, and in addition to that, of course, they are buying less from the municipality because they are storing the energy instead of exporting it and using it later. So the municipality is recovering fixed cost in its cents per kilowatt hour, for example. It will be detrimental to the municipality. So we are getting an understanding of how batteries are affecting things. And in fact, I think at the next AMEU convention, there will be a paper presented on tariffs which consider this sort of thing, and the prevalence of new systems being installed with batteries. And then, of course, on the larger scale storage, distributors are looking at where they might be able to connect larger scale storage at various places on their distribution network. But we have a presenter talking about that a bit later. So we'll leave it to Professor Gomes to do that. Then just sort of to wrap up on the small scale side, this map over here gives a sense of municipalities around the country. In the dark green, municipalities pretty much have embedded generation processing systems in place. Light green have some elements of that process in place. They're making progress. Orange, as far as we know, have no such processes in place. And gray is Eskom areas. And you can see the yellow and red markers. Those are the partners in the municipal support program. There are about 80 of them around the country at the moment. And you can see the predominance of green down here in the Western Cape, and that's because of the good work of Western Cape Province and Green Cape in this area. So you could say in one way we are we're doing quite well here, because we've covered the most populous areas and the most electricity intensive areas, where the most demand for embedded generation is going to be, at least on the smaller scale. In another way, we're not doing well at all, because look at how many municipalities do not have anything in place. And try as we might year after year, when we run this program, we try and reach out to all of these municipalities to participate in the program, be supported in developing such processes. But yeah, it's a slow business, and a lot of them seem to be not very interested, in spite of SAIEE putting their best efforts into communicating, us doing the same, AMEU supporting us with this. This remains the current situation. And I'll come back to this right at the end. Right, then on the connection of larger generators, as I mentioned, the Electricity Regulation Act Schedule 2 revision obviously opened up the licensing exemption to 100 megawatts, and that is, I believe, due to fall away as well in the next month or two. And that led to quite an acceleration of interest amongst developers, and a lot of developers contacted municipalities around the country wanting to connect in one way or another. And our help desk got quite a lot of queries asking, well, what do we do now? People are saying that we're obliged to connect them. So how does this work? Yeah, there was a bit of a feeling that it was a free-for-all. It was easy enough if a developer approached a municipality, they had to respond and buy the power, etc. Of course, it's not that simple, but that was what happened and what is happening. And in fact, there are a couple of instances where, in one instance I'm thinking of, there was a municipality that approached us. It was a new municipal manager, and what they found was the previous manager had signed a PPA with a large generator already on terms that were not at all favorable for the municipality, and as a result of an unsolicited bid. So we got Salga involved and Treasury involved, and after some legal posturing from the developer, eventually they backed down. But this is the sort, and the other examples of this as well, this is the sort of thing that that can happen, because municipalities, not all are familiar what they should or shouldn't be doing, and what their rights are, their legal constraints are, and what their obligations to developers are. But in general, connecting larger generators is something that very few municipalities have a handle. There are a handful around the country that have a handle on it, partly because it's quite a process. It's not just the grid impact side of it. There's the grid compliance side of it, which involves the Grid Code Secretariat, and there are various other authorizations and processes that need to be, and assessments that need to be put in place, such as environmental, heritage, etc. And for a lot of municipalities, it's not clear how to engage with this and what their role in this might be. There is support that is in process around this, and within the next month or so, there should be a guide for municipalities on exactly this issue. And we're going to run some training around this as well. But the situation at the moment is that not many municipalities are able to engage with this effectively. Operation Vulindlela, of course, is providing support and trying to streamline some of these issues, but that is very much still overall a daunting prospect for many municipalities. So very much work in process, I would say. And then maybe lastly to mention electric vehicles. Okay, people know that this is coming, and there is some work being done around this, and I'm aware of some work with COJ to look at some of the detail around the potential impact of electric vehicles, but not a lot of clarity around various aspects, including penetration timeframes, network constraints. So if you were to ask most municipalities what the implications are and what they should be factoring into their current planning, it's not known yet. Of course, there are potentially big implications. What you don't want is this situation with the graph over here. You know, you have a householder coming back in the evening and plugging in the electric vehicle as they park in the garage and adding to your evening peak. You really want that shifted to maybe the low demand times. How exactly do you achieve that? Those sorts of things remain questions, but as I said, work is happening. Okay, so back to the overall picture. So I've tackled a couple of these, obviously not very many, and our speakers are going to be doing deeper dives into this. But there's also some detailed work which the support program is doing on a couple of pilot municipalities, sample municipalities around the country, trying to look at what the impact is as these scenarios roll out, as this transition takes place, looking at what the hardware constraints might be when one runs into those constraints. You know, what sort of planning decisions do you need to make now to cater for those? And then, of course, on the business side and the revenue side, the municipal business model side, how it's going to impact that. So I think probably next year's AMEU convention, there will be some results from that study. But I think that level of not at the higher level, but at the detailed level, working with specific municipal situations is going to be really useful. Right, then in general, maybe the last point is that this is quite a cocktail for a municipality to absorb, and there's a big jump from that to this. And on top of that, there's the unbundling, there's the competitive power market. So we're asking quite a bit of municipalities. And last comment is around the municipal capacity in this regard. And back to these orange municipalities here, which are often the ones that are struggling to even be viable entities as they are So if I was to give a sort of high-level thumbsuck as to summarize the municipal capacity situation, I would say maybe 25% have the capacity to embrace the future, can be proactive from within their own resources and absorb and plan for this future. Maybe 25% are functional entities, but they wouldn't necessarily have the internal capacity to accommodate these challenges, but could with support. And then maybe around 50%, it would not be wise to put any additional challenges on their plate. They are not necessarily well-functioning entities as they are, and their focus needs to be much more on getting the basics right. So as we think about moving into what seems to be a really interesting and exciting future, let's just keep this municipal capacity reality in mind. And if we need all of these municipalities to be part of the transition, we might need to think carefully about how that's going to work because of the very limited capacity situation. If we don't need them to be actively, proactively part of it, then do they get left further in the backwater? So just some ideas to keep in the back of our mind as we move into the inputs from the various presenters.